Hi everybody. Over the next two videos we're going to look at how to convert radians to degrees and then how to use radians with regards to segments, sectors and arc lengths. But we'll start with the basic idea of a radian. A radian is the angle described if the arc length is the same as the radius. So in this case we have a radius of 6, an arc length of 6, and the angle between it we're going to call 1 radian. If we went 2 radians, the arc length would be 12. The radius would stay the same. Now if we went 3.142 radians, we would get 180 degrees, and the angle would be pi radians, and the arc length would be 3.142 times 6 centimeters. So a radian is quite a useful measure in that it makes finding arc lengths quite simple, and we're going to look at that in the next exercise. But for now, what we need to realize is that if the angle is 1 radian, the radius will equal the arc length. If it's 2 radians, the radius will equal, the arc length will equal twice the radius. And if it was 3 radians, the arc length would equal 3 times the radius. And we have a special measure, pi radians, which will equal 3.141 times the radius. That'll be the arc length. And it'll form 180 degrees. Now, we can use that property that pi radians is equal to 180 degrees to help us find other angles. So if we wanted to know what pi on 8 radians was, we could divide both sides of this equation, and we'll find out that it's by 8, and we'll find out that it's 22.5 degrees. Similarly, if we wanted to know 2.3 radians, so 2 radians and a bit, how many degrees would that be? We could multiply pi radians by 2.3 on pi. The pi's will cancel out and just leave the 2.3. We need to do that to both sides of the equation, so we go 180 times 2.3 on pi, and we find out that 2.3 radians is in fact 131.78 degrees, or rounding to no decimal places, 132 degrees. Now I've got some formulas down below that you can memorize instead of using this balancing type method, but if you're very comfortable with multiplying fractions, it is quite a simple way of doing it. Now we don't have to only use radians for circle problems, we can also use it for triangles, but we have to make sure that our calculator is in radians mode. So if this angle here is described as 1.2 radians, we can use that for trigonometric ratios. So in the case of this problem here, this would normally be a tan problem with opposite and adjacent and an angle. Tan of 1.2 radians is equal to the opposite, it's x divided by 5.2. We rearrange the equation to make x the subject. We get 5.2 tan 1.2. We make sure our calculator is in radians mode. We put that in and it gives us 13.38, or 13.4 to 1 decimal place would be this value of x. No degrees in sight. We can do it all with a radian measure. Now, if you haven't already, do exercise 2b and then come back here and I'll show you another method of finding degrees in radians. Okay, I'll assume that you've stopped and come back, or else you just want to see the rest of this before you start the exercise. Another way of converting between radians and degrees, if you're not comfortable with the balancing method up above, is to memorize this little formula here. Theta degrees divided by 180 equals theta radians divided by pi. Now if you manipulate this equation, you can either find theta radians or theta degrees given a conversion problem. So if you're looking for degrees, multiply both sides by 180 and you get 180 theta radius divided by pi. If you're looking for theta radians, multiply both sides by pi and you get theta degrees pi divided by 180. So for instance, if I wanted 2 radians, that would equal 180. So if I wanted 2 radians in terms of, I'm going to sit and do this problem over here. Theta radians equals theta degrees on, let's just write this in full. Just say we wanted to know 2 radians in terms of degrees. Let's write down the degrees formula. Theta degrees equals 180 theta radians on pi. That's equal to 180 times 2 divided by pi, which equals 114.59 degrees. Now we could do this backwards if we wanted to. Theta radians is equal to theta degrees times pi divided by 180. If theta radians was 114.59 degrees, we'd multiply that by pi divided by 180, and that would give us the same answer backwards, which would be 2 radians. And that's what these two expressions here are trying to show. For some, this is a much easier way to do it. All right, thank you. That's all for this. And then the next exercise we'll use radians for sectors, segments, and arc lengths. Thank you.